All right, you guys can see it? Thumbs up if you can see it.
Yep.
Yeah. So hi, I'm Christina. I mean, Brian did a quick intro about me, but as he said, I'm an innovator at the Knowledge Society, and it's a human accelerator program for teens ages 13 to 17. We're basically exposed to a bunch of different emerging technologies and pushed to use their applications in order to impact billions. So a couple of weeks ago, some of my friends and I participated in this global AI hackathon, because what else are we supposed to do during COVID? And the idea that we came up with, and to some extent we actually ended up building, was actually pretty cool. And that's what I'm going to be sharing with you guys today. So a lot of people see the COVID-19 pandemic as a mashup of this. You see the headlines, you see the companies trying to work on the vaccine and all of that, but this isn't the end. A lot of people see this vaccine as the end-all solution for COVID-19, but what they don't realize is that if we don't optimize the effects of the vaccine, we won't really be making that much progress. Both the CDC and the WHO have released a preliminary plan on how they're going to tackle this limited supply of COVID-19 vaccines by putting people into various categories. And some of these categories are like healthcare workers, frontline workers, above 65. There's a bunch of various categories that we didn't get to include in our simulation, but those are a couple of the ones that we ended up including. But the reality is we're only going to have a limited number of vaccines. So therefore, prioritization is key. To make sure that the vaccine performs to its fullest potential, it's essential that the people who need it the most get it first. And we're here to make sure that that happens. Our solution was to create an AI vaccine prioritization model that makes sure that we're vaccinating the right people at the right time, while making sure that the overall infection rate is as low as possible. So I'm going to outline kind of how we did this in very basic terms. So basically what we did is we analyzed Newmarket. And for those of you who aren't familiar with Canada, Newmarket's a tiny city, kind of north of Scarborough, I'd say. Newmarket has 90,000 people with 1,000 COVID-19 patients, but due to limiting computing power, we had to make our simulation pretty small. And instead we only had 1,000 people living in Newmarket with 100 COVID-19 patients. And then we use proportional relationships in order to figure out how many people within a Newmarket would be in those various categories that the WHO outlined earlier, like healthcare workers above 65, etc. So at the beginning of the simulation, each person is assigned a vaccine score based on their demographic data, which is a number between 0 and 1. The lower your score is, the sooner you're supposed to get the vaccine. And once that's been established, our 365-day simulation starts. So in our simulation, every day is the same. Each person goes to work or school, they go grocery shopping, and then they go home. And then the computer counts the number of interactions that each of these people would have had. Then the computer looks to see if each person is eligible for a vaccine. If a vaccine is available that day based on their vaccine score that we gave them earlier, in our simulation, we also assumed that there would be a new vaccine available every 14 days as with 200 people vaccinated as well. And once they get their vaccine, we assume that they're 100% immune. Then it updates their health, which is like if they're sick, whether they're dead, and if they're not working because they're in quarantine, etc. All of those different little kind of check boxes. So here's where the exciting part comes in, artificial intelligence. We created a neural network, but we had to create a special loss function because we had inputs, but we didn't have any outputs. So we added some random weights at the beginning into the layers to create an output and multiplied that by our outcomes to get a loss function. Then we put that through the training network and repeated it 150 times, and the neural network outputted the lowest loss value. So I just want to show you this graph with the mortality rates in our simulation. You can see how the AI vaccine mortality rate is significantly lower than both the random, which is the first come, first serve basis of vaccine distribution, and then if no vaccine was available. And just to emphasize this, our AI prioritization model decreased the mortality rate by 67% to compare to the no vaccine model that was 50% compared to the first come, first serve basis. That means that we can save hundreds of thousands of lives if we just put more intention into prioritizing the vaccines. So what's next? This approach can be scaled up significantly to take into account more interactions and become a more accurate simulation, because as I mentioned before, we did make some kind of assumptions at the beginning. But this approach actually would work for any distribution of a limited resource. Overall, this technology has so many applications in the healthcare field, and I'm so excited to see them outweigh. And more important than its technical potential, this model has the potential to save, again, hundreds of thousands of lives worldwide. And each of these lives are, again, someone's brother and mother and uncle, which means, to be honest, it's an algorithm of hope. And this is what I consider the future of healthcare. And that's it. So I'm willing to answer any questions that you guys have based on TKS, or even just like this model that we made for our hackathon. I'll stop sharing my screen now. Okay. No questions.
I'm sure someone has questions.
How many in our simulation didn't take the vaccine? That's a good question. To be honest, because it was just a hackathon project and we basically built the whole thing in 2 weeks, the whole kind of idea was just that we assumed that everyone did take the vaccine. Like we assumed that every single person was eligible and were going to take it. So we didn't really take into account on the people that wouldn't. But again, that was another assumption that we made under short time. It's cool if we don't have any questions. That means that it's hopefully cool. Okay.
More questions. What software did you use primarily?
So we used, I believe we used, well, we coded it in Python, and then I think we used PyTorch, but I could be wrong because I think that's what we did. Again, I wasn't the builder, I was the pitcher, and we had like a developer on our team that was the one that basically coded the entire thing. But yeah, so that's what I believe that we did. I have some other questions. Are you working on improving the AI to make it more effective? That's a good question. So again, like I said, the developer on our team, she's currently working on it to kind of improve it and make it more effective again and decrease the assumptions that we made in the beginning. So, I mean, yeah, I would say that she is trying to improve it. I'm not as involved in the project anymore, trying to work on different things, but yeah. I have another. Why did you decide to start coding and using AI? And what advice would you give to someone who has very little experience in coding? So I think personally, why I started to get into coding, it was actually pretty recently, I would say. I've been doing it for about 6 months. And the reason why I did is mainly because of TKS and how technology is the future. And I realized that if I have this kind of ability to code, I can build so many things on my own. And like that whole like little power that it gave me kind of inspired me to like keep going and to create more projects. But what advice would I give to someone who has very little experience in coding? I would say just like figure it out and like keep going and like looking into courses. One of my favorite courses is the Code Academy course on Python. That's the one that I did to learn. But I would just say, like, if you have little experience, like, just try building it, figure it out, and definitely go and ask people when you need it. I think that's also super important. How many people worked on the program? So it was a team of 5 of us. Would the vaccines be a pickup thing or would they be delivered? So we assumed that it would be the same process that's kind of happening right now in Canada. It would be that you go to either your doctor or you go to like a local like pharmacy and you go and get the vaccine there. So that was kind of what we assumed as well. May you elaborate on the program you're in? Of course, TKS. I'll put it in the chat as well after I'm done. So again, as I said, it's a human accelerator program. I think what makes TKS like very different from school, it's kind of a accelerated future version of school because it follows a curriculum, but the curriculum is like solely based on emerging tech. Like for example, today we did like BCIs. So we like went in deep into brain computer interfaces and like the applications of that and how we can use that to again solve super important problems. So we learned that sort of aspect, but then we're also exposed to like entrepreneurship and like startups and how to like start your own company and how to pitch and again how to public speak, do things like this. So it's kind of just like a mix and a jumble of like everything. So I would say if you're interested in entrepreneurship and tech, or even if you're just interested in like impacting people and like starting your own company again, like I would definitely recommend TKS to anyone who's interested in that. So go ahead and apply. Um, After more updates to the simulation, what assumptions do you see turning into statistics, and how would you improve from the stage of assumptions and get more solid answers? Um, I think I mentioned a bit of that earlier, but the reason why we initially made all of these assumptions was just because of time, first of all. Like, we didn't have enough time to take into account all of the different aspects because it is a complicated problem. And we did have like a week to do it. But I think if we were to improve it, um, improve improve from the stage of assumptions and kind of eliminate those, I think that it would come more to the beginning part of our code, which was kind of like outlining. We were kind of defining what a person is, and that's where many of our assumptions came into. So I think we would have to go into there and redefine the actual person in order to do that. Um, Last question: what ways could a similar simulation be adapted to combat the current pandemic? Um, could you expand on that? What ways could a similar, if you want to expand on that, like something exactly like the one that we created, or I'm gonna assume that it's something that we created. Um, I think that was the whole purpose of ours, was to combat this current pandemic. But I think that if I were to create another a similar simulation, that's a good question. um I think I would, if I had like the power, if I had magic wand and was able to do something right now, what I would do is I would go deep into like the categories that the WHO mentioned. So I mentioned earlier, if you just search it up online as well, the WHO has like released a document on how they're thinking of tackling the problem. And in that, they kind of like put those different categories of people. I think I would pick one category and I would create a simulation that would categorize those people in that specific category. For example, like I would choose above 65 as like my only category, and then I would figure out, okay, like how am I going to prioritize like above 65 with like who's a heart patient? How am I going to prioritize like an above or a 70-year-old patient with diabetes, for example, and figure out like where they would go in the chain. That's probably what I would do if I wanted to create a similar simulation. But I think that was the last question. So thanks, guys.